So what I'd like to do is I'd like to just spend just a few minutes showing you how to design a class from scratch, then use that class in a main program, then discuss the value of automated testing. So everybody probably has a bank account, and you know when you have a bank account, like a checking account, you have an account number and a balance, like you have $50 in your account, and then there's behaviors, like you can get the balance, how much do I have in my account? You can deposit money into the account, or you can withdraw money from the account, right? So whenever we want to model software after some system or real-world process, we always try to brainstorm for what the states and the behaviors are of that real-world system. So in this case, in a checking account, the states are you have an account number and a balance, and the behaviors are you can deposit and withdraw stuff. So what I'm going to do now is I'm going to simulate this all in NetBeans and then write code that makes it work, and then write code that proves that it's right. Because ultimately, when you write your own classes, you want to make sure that the classes don't have logical errors in them, and those are the errors that are very difficult to catch, those logical errors. Okay, so I'm going to start here with a brand new project. I'm going to just go all the way from square one here, and let me just put this somewhere where it's not going to get blown up. All right. File, new project, and I'm going to call this account demo. That's fine, and I guess I'll put it there. That's fine. I don't really care. All right. So the first thing you'll notice is I have account demo Java. This is my main class, but what I'd like to do is I'd like to build another class called checking account that models how a real checking account works and has these states and behaviors in it. Okay? So here goes nothing. I'm going to go new package, first of all. I'm going to make a new package. And I'm going to call this accounts. Let's call it fudge accounts, just to be fun. And then I'm going to make a new class called checking. I could call it checking account, but you don't want to watch me type, so checking's good enough. Then I'm going to do some documentation here. I'm going to say this simulates checking account. So every class has states and behaviors, right? The states are variables, and these are always private. And what does private mean? Here we go, studying for the test. The only thing that knows about a private variable is this class itself, right? This class account demo, when I use my checking account, it has no idea what I'm about to do in here. These are the internals of it, right? You step on the gas, the car goes, you open up the engine and watch it, you see pistons flying up and down or whatever, right? That's all internal, right? But you don't need to see, you don't even ever need to open up the hood to drive a car, right? And that's kind of the idea. We call that an abstraction. The name that we use is encapsulation, is the term that you would get tested on. Encapsulation is a property. It's a characteristic of object orientation where we hide the details because you don't need to know the details in order to use it, right? So in here I'm going to have account and then balance. And balance is probably going to be a double, and the account is going to be a string, because I don't do math on it, right? So your account number is 1, 2, 3, 4, 5, but you're not adding that, so just keep it as a string. And now I need to make a constructor, because every object needs a constructor. The constructor says, the constructor is a blueprint for the class that tells how to make objects, right? So I'm going to call this public checking. And since I have two states that I need to set, if I were to make a constructor with no arguments, I should set those to 0, like this. This dot account is empty string, right? And this dot balance is 0. Why am I using this? Do I need to use this? Can I take this out? Yeah, I take this out, still works, right? This allows you to use dot notation. And dot notation is your friend because dot notation tells you what are the properties and methods of the object you're using, right? In the case of this, it refers to this object, right? That's why it's this. It's the class that you're in, right? So I'm in the checking class. So this refers to the properties and methods of the checking class. It's a shorthand for typing checking dot. I just type in this. I don't need to use this. If I'm smart, I could just say account equals, right? But I'm not smart, and I don't do things well, so I do this dot. Oh, account. Beautiful, right? Now, if you're going to make an account, will they let you go to a bank and make an account with no account number? No. So that's required. So that belongs in the constructor. So I would say string new account, and then double opening balance, right? Because you can't go to Chase and get a bank account and say, well, can I start with no money? They'll just laugh you out of the place, right? All right. So now that I've got this written, this is called the signature of the method. So the method has how many inputs? 1, 2 inputs, and it outputs a new, because it's a constructor, it outputs one thing, a new object of this class, right? So now that I've got the signature written, I can write a Java doc. So to write a Java doc, you use /2 and press enter. And now you just describe in plain English what this method is for. Doing this for yourself, it doesn't make a lot of sense. But if I'm writing code and I want you to use it, I should use JavaDoc so it explains the intent behind what the methods are supposed to do, right? So I will say creates a new account, checking account. The account name or number, the opening balance. And you'll see what these do in a minute. I'm going to show you the impact of doing this. This is a very powerful thing, Java docs, because they give you a clue as to what's happening. For example, if I do this dot, right, you see it says account, and there's no Java docs for that. But if I had a constructor, I can't use the constructor inside the class. It would have this information in the constructor, right? So to finish this out, I should say this dot account gets new account, right? The argument that you send into the constructor gets assigned to the state, and then the argument, this balance, equals open balance. The argument that comes in for the opening balance gets saved in balance. Okay? Now these internal values here, they are available in all the methods because they were defined inside the class. So let's try to write our next method, public double get balance. Takes no inputs, and as output, it's going to tell me what the balance is. So this should return what? Yep, should return this dot balance. Or you could just have it return balance if you're not paranoid like me and you don't need to say the word this all the time, right? Now I should write some Java docs for this. Whoops. Tells you the current balance on the account. Now I have no idea if any of the code I'm writing is right. All I know is that it's syntactically correct, right? Because if it was syntactically incorrect, I would get this wonderful red mark here, right? So all I know is that the code I'm writing will build, but I have no idea if it's right. And I want you to understand that that's okay, because it's your job to figure out if the code you write is right. Okay? And I'm going to show you how to do that with unit testing in a bit. So there's get balance, and what does it return? The balance as double. Maybe you could say that. You could say it if you want, right? All right, let's write a couple more here. How about public void? What does void mean? What am I returning? Nothing, right? Public void deposit. Now, should I deposit? If I do this, what am I depositing? Nothing, right? Because no inputs. That doesn't make any sense. I should say deposit double amount. That's the amount of the deposit, right? And then I should say this dot balance equals. Let's suppose you don't know what to write here. Do you know what to? Who knows what to write here? Don't tell me if you know. Do you know? If you deposit an amount, right? what should it do to your balance? Increase your balance, right? But let's suppose you don't know how to write this and you write it like this, right? Is that showing a red error? No. Is it right? No. But let's figure out why it's wrong later and then fix it. Okay, this is like the power of unit testing, is you just write your code, then you deal with whether or not it's correct later on. So I'm going to say this should increase your balance by the amount. Amount to increase balance by. How's that? Okay, let's keep whipping along here. Public void withdraw. How's that? Double amount. And this dot balance minus amount, or equals minus amount. I don't know. I'm guessing here. I know what the answers are, but let's just play around with this for a bit. And I'm not going to write Java docs here because you've seen me write enough Java docs already, and I don't want this to take forever. So the last thing I want to do is whenever you have a class, right? Well, I have enough here. Well, let's go to account demo and try to use our class. All right. So I'm going to come down here. You got to know how to construct the object of the class. So it should be checking C equals new checking, right? But it doesn't know about checking because I didn't do a import. So I'm going to do Control-Shift-I. That imports fudge accounts checking. Boom. Now watch this. Where did this come from? I wrote that. Right? Creates a new checking account, new account. Now, probably what I should do is put the types of the parameters in here. That would probably be better documentation. So if I go up here and it says creates a new checking account, booyah, right? And then as a string, as a double, right? Save that. Let's go back here. Let's try it again here. I'm hitting Control Space, by the way. Oh, why did that not? Oh, now it doesn't want to do it. All right, well, let's just do this. So checking account, I'm going to call it the Mike account, and my opening balance is going to be $500 and a penny. Right? So now, if I do this, system.out.printf, or println, C, hey, that doesn't have any problem, right? Let's run it. It says fudge accounts checking. You might be saying, why when I print this object does it do that? Okay, and I'm going to let you in on a dirty little secret. Whenever you use println with something that's not a string, it tries to convert it to a string. Every object can be converted to a string automatically. Whether it makes any sense, that's another story. Okay? So if you want your objects to print gracefully like this, you need to write a method to do that. And this is the next lesson, is you do public string to string. Why do I need override? Because there already is a toString method there. I want to change the behavior to use my toString, not the toString that's already there. If I leave override off, it's not going to work. Okay? So in here I want to say return, well, let's get fancy. Let's say string result. Well, that's too much for typing. R equals account name plus this dot account. Right? I could do this, right? You're used to printf, right? So I want you to think about this. System.out.printf. What if I did this? Account %s, new line, balance, percent or $% to dot to f, new line. And then I'm going to say this dot account, this dot balance. Can you figure this out? This is going to print out the word account, then it's going to print out my account number, then it's going to move down a line, then it's going to print out the balance, then it's going to print out a $, and then whatever I give it to 2 decimal places, then a new line, and account and balance. Now here's the cool thing. I need to return a string. I don't want to print this out. There's actually a command called string.format, which is the same thing as printf, only it returns a string rather than printing. So I can say return string format, and it's the same as if it did the printf. That saves me from doing a lot of this plus this with my strings to make it look right. Okay. So now that I have that, let me run my program again. And now I get account Mike balance 5001. Sweet, huh? Now why is it printing like this? Because I'm just saying println C, and C is not using the default toString anymore. It's now using the overridden toString. Yes, sir?
That was my question. Can you repeat that, please?
Okay, so all of a sudden it is now printing it out using this toString because of the override. Before, it was using the default toString, which just prints out a bunch of garbage. It prints out the name of the object and an internal ID, right? So the fact that I added this override in there says, don't use the default toString, use the one that I just wrote, which is right here. And this one here says, make a string that looks like this and return it. And then that's what gets printed here. When you say C, it's the same as saying C.toString. That's the secret. That's
This one is your default one.
Yes. Yeah. Okay? So now you could write all sorts of code, like how would I test to know that deposit works, right? You have a balance of $100, then you deposit 50. What's your balance? 150, right? We all know this because we all like money, right? But the thing is, you could write a lot of code before you know whether or not all of your methods work, because I have 3 methods here. I have withdraw, deposit, and get balance, and they all need to be tested. So this is why unit testing exists, because unit testing allows us to write code which tests our method. So let me just show you how this works. And this was the other part of the lecture. So I'm going to do new, and then I'm going to go to, where's the tests? New. They don't have it installed on here? Unit tests, JUnit tests, there we go. I'm going to call this checking tests for checking account, right? And that looks good. Use the latest version. There it is, checking test. Now there's a bunch of boilerplate code that it puts in here. I'm not going to use any of this, and just so that it's easier to read, I'm just going to get rid of it all, right? There's my constructor for checking test. I'm not doing anything in there. I don't even need that. And then now what I'm going to do is I'm going to write some test methods. So when I write test methods, rather than saying override, they say test. And now I'm going to write a public void. It doesn't return anything. It's going to print stuff out. And let's say test balance should be the same as the opening balance. When you write method names for your tests, you usually will use these really long names to describe what the hell's going on. You don't write test balance, right? That's not good enough. You have to write test balance. Usually what we do is we say, we use a language called given, when, then, right? So given when I have a test balance, it should be the same as the opening balance, right? So I kind of addressed all of these issues up here, right? All right, so now that I know that, the way you test is always the same. You always arrange, then act, then assert. These are just mnemonics, right? So arrange means you set things up, and you set them up the same way. I would say, like say double expected balance is, give me a number, any number. $43. And let's do 56 cents. Why the hell not, right? So I expect that, right? So then I'm going to make a checking, new checking, and we're going to say it's Mike, and then expected balance. Oh, got to fix my import there. So now I have this checking account. So let's act. Let's say double actual balance is, how do I get the actual balance? It's C dot get balance. That gives me the balance. Do you see how fast I did that? Did I do any typing? I did 3 keystrokes. Object, dot, enter, once I got the method. Bam. Right? That's the advantage of dot notation. Dot. And then look at my Java docs. Tells you the current balance on the account. Tells me what it does, right? It's the beauty of it. Okay. So now that I have what I expect and what I got, I just check to see if they're the same. So I would say assert dot assert equals assert equals, and I want that. And I want to say expected balance, actual balance. Now if you run it, it doesn't work. You have to run it as a test. So that's under here, it says test file, control F6. When I do that, I get a special window. It says passed. Test balance should be the same as opening balance, passed. So you might say, well, what does that mean? Well, this is how writing tests makes you a better programmer, right? Because what I did was I picked some number, and I said, well, if I make a checking account with an opening balance of that number, then I ask it for the balance, they better damn well be the same. If not, I did something wrong, right? See, writing tests is very easy, but it's also a great way to become a better programmer because you get to learn how to use your own methods or other people's methods, right? So let's try this again. Let's try this test, and let's do public void. The light bulb will go off after you do another one of these. Let's do test deposit. Balance should be $10 more than opening balance, right? Think about it. If I have an opening balance of $43.56 and I deposit $10, what should my balance be? $53.56, right? We all know this because we all love money, right? So let's do this. I'm going to copy a lot of this because you don't want to watch me type, although usually when they tell you to write tests, you should never copy them. You can keep your eyes on the top and your eyes on the bottom, but, well, maybe I'll do that then. So I'm going to say double expected balance. I'm going to do it differently. I'm going to say double opening balance is $44.10. And then double deposit is $10. And then let's say checking C equals new checking account. Let's call it Dave. And let's give it an opening balance. Beautiful, right? Then let's do an act. Let's say double, actually we're going to say C dot deposit. Let's put our deposit in there, right? Put our $10 in there. And then we'll say double actual is C dot get balance, right? And then we can say assert dot assert equals, and I expect, first comes expected, right? So expected would be, we can add it up, or we could do some, we could say opening balance plus deposit, or we could just go right for the straight number, $54.10. That's what I expect. And then what I got is here in actual. Done. Test it. This test failed. It expected, so get this, it expected 54.1, but it got 10. All right, so what do you know at this point? You know that this code has a logical error in it. It's not right. So let's go ahead and take a look at that definition. So let's see, I give it 10, and it sets the balance to 10. That's not what we want, right? We want to say that add 10 to the balance and make that the new balance. So how do we say add 10 to the balance? It would be this, right? That adds 10 to the balance. How do I make this the new balance? And you can put parentheses around it if you want. Right? So the new balance is whatever the current balance is plus the amount. That does a deposit. Let's see if I just save it, and now rather than change any code, I just rerun my test. Watch. Am I still running my test? Oh, I got to go into the test. I can't run it until I go into the test itself. I got to go in here. Now it passed. Beauty. See that? The nice thing about writing tests is when you write all your tests, you can improve the code in the methods, and then to make sure you didn't break anything, you just rerun the tests, and if they all pass, good to go, right? So let's think about, as a final exercise, let's write the last test. So the last test is for withdrawals, right? So, I don't know, let's say public void. By the way, the numbers are arbitrary, right? This could be $99, it's still going to work, right? Because what you're really trying to test is, is it 10 more, right? So let's say public void test withdrawal. Balance should be $5 less than opening balance. I'm going to write this one a little differently, but same idea. Do I have to test it to see if it's $6 less? If I test it for $5 less? No, none of that really matters, right? Because numbers are numbers, right? The math isn't going to be broken because the math is intrinsic to Java. What's going to be broken is that you multiplied instead of added, right? That's what's going to be broken. Okay. So let's say I'm going to repeat some of this stuff. I'm going to say, I'm going to take this and put it down here, even though I told you not to do this. So I'm going to say the opening balance is $44 even. Let's make it a nice even $40. And then let's make a new checking account. Then let's deposit $5 directly. Then let's do double actual, let's get the balance. Let's get the balance. And then let's assert, it should be 45, right? $45. And whatever we got, are they the same? Right, so now what I'm going to do is I'm going to open it up with 40 bucks, deposit 5. When I get the balance, it should be 45. What is it? I don't know. Let's find out. Let's test it. They all passed. Now, I find that really, really shaky because I thought I wrote that method wrong. Let's take a look. Balance minus amount. Oh, there we go. Because see what I did? I deposited. I want to withdraw. Of course it's going to pass. That method's right. That's not the method I'm trying to test. What else did I do wrong? This is why you don't copy and paste your tests, by the way, right? What else did I do wrong? Should it be 45 if you withdraw $5? No. Should be 35. See? That's the beauty of testing, by the way, is you have to know your own code to write a test. So a lot of you are like, is this right? And I push that back on you. And the reason I push that back on you is in order to be an adequate learner of Java, you really have to know whether your own code's right. And doing so is, can you use the code that you wrote? Let's give it a shot. Test. And now it should fail, and it does. Let me show you that again. Expected 35, but got 5. So I have a feeling we've got the same kind of problem here, and if I look, we do. It should be this balance minus the amount. There, and let's give that a test. Let's go back here to the test file and give it one more test. And then when the lights are green, you're done, because everything works, right? But the idea is you should have at least one method for each, one test method for each of your methods. When we start to learn about branching and there's more than one situation that can occur, then you might need to write different tests for different scenarios. Like one thing we didn't test is what happens if I try to deposit negative $50. This is a great trick we love to play on, in the early days of banking, this is how you could make money, right? You like deposit a negative amount and then all of a sudden, I'm sorry, you withdraw a negative amount, right? You wouldn't deposit it, and that would be stupid, right? What happens when I take out negative 50? All of a sudden, if I have $100 in my account and I withdraw negative 50, you probably learned this in algebra class. If you have two of these minuses, they somehow go together and make a plus, right? And then it's like, now I got $150. I just cheated the system, right? It's like Office Space all over again. Okay. So we haven't checked for that kind of stuff. So that's why you can't sell this code to JP Morgan Chase. It's just not good enough, right? But you can see where you would want to write all sorts of tests, right? For all sorts of scenarios. Like what happens when somebody enters a bad value that I don't want? Is that going to blow my system up, or did I account for that somehow in my code? So while basic testing is great, it has its limitations. The true advantage of testing is now that you've done this and you have an idea that these are right, when you go here and you write a program that I tell you to write, like deposit $50, withdraw $80, if I don't give you screenshots of exactly what's going to happen, you could write the code and know for yourself if it's right. How do you know the code you write for me is correct? Many times you're trying to match it up with the screenshot, right? You're trying to say, I want to make it look like the output. But in life, we don't always get the output. That's not how it works, right? In IST 256, most of the time you're going to get the output, right? But in life, you don't always get the output. So you have to have a way to know if what you're doing is correct. Okay? So hopefully that helps you figure things out. I guess one of the last things that I didn't talk about that might be on the test is, and I'll bring it up now, is these private members. This one never changes account, right? But the balance does change when I do a deposit or withdrawal. You see that? So we call this immutable. And this one is not immutable. Because in computer science, we love double negatives. Immutable means it does not change. So this says this does not change. Just like completely stupid, but that's how they talk. So when we say the word immutable, what we're meaning is that the object's data doesn't change. You create that object, and then it never changes. Okay. We generally want to try to design our classes to be as immutable as possible, because you can trust that you're not going to introduce certain kinds of errors, which I can't really describe yet because we haven't learned them, into your code if you have code that's immutable. I always get that confused. So if you see that on the quiz, hint, hint, now you know how to answer it.